Can you fit an entire music file into a QR code? And I don't mean storing a Spotify link. I mean the entire music data itself, completely offline. Imagine printing a QR code on a piece of paper, scanning it years later, and hearing the song without an internet connection, without a server, without any external database. Just the paper. This idea came to me when I was trying to build music cassettes that store songs, except instead of using magnetic tape, they'd use QR codes. Today, streaming services charge you every month just to access music you don't really own. Sure, you could keep your songs on a USB drive. But wouldn't it be way cooler if your music collection was literally a stack of paper? So in this video, I'm going to see if it's actually possible to store a full song inside a QR code. Then I'll take it one step further by building a doomsday music streaming system that lets you stream music remotely with zero internet connection. Let's get started. Part of this project is sponsored by React's technology. More on them later. Trying to cram huge amounts of data into a QR code isn't a new idea. In fact, there are videos of people storing entire games inside QR codes. But music is a completely different challenge. A game is mostly instructions. A music file is mostly raw data. Even a 2-minute song contains millions of bytes. So to pull this off, we have two problems to solve. First, we need to compress the audio file as much as physically possible without destroying it. And second, we need to squeeze as much data as possible into a QR code printed on a piece of paper. Neither of those is easy. Let's start with the first problem, the music file itself. I have this song, it's only 1 minute and 34 seconds long. And even after being compressed as an MP3, it's still 2.9 megabytes. Now compare that to the biggest QR code you can make, the version 40 QR code. It can store only about 2.9 kilobytes of data. That means I'd need around 1000 QR codes just to store this one song. So if I want to fit this into a QR code, I somehow need to shrink 2.9 megabytes down to less than 3 kilobytes. How do you even do that? Well, that takes us into the world of data compression. There are two main ways to compress data. The first is lossless compression. It finds patterns and removes redundant information. But when you decompress the file, you get back the exact same data. The second is lossy compression. Instead of preserving everything, it intentionally throws away information that's considered less important in exchange for much smaller file sizes. MP3 is already a lossy compressed format. Most of the unnecessary data has already been thrown away. That means there's almost nothing left for a lossless compressor to remove. So how on earth will we make it more than 1,000 times smaller? The solution is AI. No, wait, don't close the video yet. Hear me out. There's a type of AI called an autoencoder that's actually perfect for this problem. It contains two neural networks. One is called an encoder that works like a funnel, taking in large data from one side and squeezes it into a tiny representation called a latent space. Then on the other side, another neural network takes that tiny representation and expands it back into something that resembles the original. So here's the idea. What if we split the two apart? The encoder compresses the song into this tiny representation. We only store this inside the QR code. Then a smartphone app can contain the decoder. It scans the QR code, reads that tiny representation, reconstructs the audio, and finally plays the song. In other words, instead of storing the song itself, we are storing the AI's compressed representation of the song. If this works, it could shrink the file far more than traditional audio compression. Only one way to test it. I had to create the AI compressor. Luckily, I didn't have to train the AI myself. Meta had already built one specifically for compressing audio. It's called encodec. So I wrote a Python script that feeds my song into encodec and saves the compressed representation as a tiny binary file. The only setting I really had to worry about was the bandwidth. Lower bandwidth gives you a smaller file but worse audio quality. Higher bandwidth sounds better but creates a larger file. So I started with 3 kbps and it compressed my 2.9 megabyte song down to just 22 kilobytes. Wow, I wasn't expecting that. That's more than 1000 times smaller. So I went further and dropped the bandwidth to 1.5 kbps to see if it can get even smaller. Now the file was only 11 kb. But as a wise man once said, size isn't everything. If the reconstructed audio sounds terrible, then none of this matters. So I wrote another script that reconstructs the song from the compressed data. Let's hear what it sounds like. First, the original audio.
Lights, they shining so bright, we're gonna dance through the night. Hands up, feeling the heat, move your body.
Now the 1.5 kbps audio.
Lights, they shining so bright, we're gonna dance through the night. Hands up, feeling the heat, move your body to the
Yeah, that's not great. Now here's the 3 kbps version.
lights. They shining so bright, we're gonna dance through the night. Hands up, feeling the heat, move your body to the
Honestly, that's way better than I expected. It's definitely not perfect, but considering it squeezed almost 3 megabytes to just 22 kilobytes, I'd call that a success. There's just one problem. Our QR code can only hold about 3 KB. So even after all that compression, we are still about 7 times too big. By now I'd pushed the audio compression about as far as I reasonably could. If I wanted to fit the song into a single QR code, there was only one option left. Make the QR hold more data. My first thought was simple. QR codes waste a bit of space on error correction. That's why they still work even if a part of it is torn or gets scratched. So what if I just got rid of it? I tried, it barely made a difference. I needed something more drastic. That's when I found something called jab codes. Instead of using just black and white, they also use color to pack much more information into the same space. So I generated one using my compressed audio. And this is what it looked like. It looks like TV static. The pattern is so dense that a smartphone camera can't reliably distinguish the individual colored squares. It's almost impossible to scan. So after several hours of trying different barcode formats, I realized maybe I wasn't solving the right problem. I'd been obsessed with fitting the song into one QR code. That's when I remembered something. Some old vinyl records stored music on both sides. Halfway through the album, you'd simply flip the record over and keep listening. So why not build my paper cassette the same way? Instead of one impossible QR code, I'd use 8, 4 on the front and 4 on the back. The phone app would scan both sides, stitch all 8 pieces back together and hopefully play it. There was only one way to know if it'll work. I wrote a code that takes the compressed audio, splits it into 8 chunks and generates 4 QR codes for the front and 4 for the back of the cassette. And this is the result. An entire song stored on a single piece of paper. Honestly, I still find it hard to believe that we fit all this into this. But we are not done yet. We need a way to play it. So the next step is building a mobile app that scans all 8 QR codes, stitches the data back together in the correct order, reconstructs the audio, and starts playing the song. But I wanted to take it one step further. A fully offline doomsday Spotify that streams the music to my phone when I'm on the go. So how do you stream data with no internet connection? That's where today's sponsor Reax comes in. They build wireless modules for IoT projects including LoRa, Bluetooth, GNSS, and a whole range of other wireless technologies. Their LoRa modules are especially nice because they're easy to integrate, support simple AT commands, and let you get a prototype up and running without having to design an RF circuit from scratch. For this project, I'll be using a pair of their LoRa modules to build my own tiny offline music streaming system. So let's see if we can turn this paper cassette into something that streams music from across the locality without internet. If you want to purchase such modules too, you'll find a link to React Technologies in the description. To make this work, I'm using a pair of React's RYLR998 LoRa modules. LoRa stands for long range, and that's exactly what it's designed for. Unlike Wi-Fi or Bluetooth, LoRa trades speed for distance. Depending on your antenna's settings and environment, these modules can communicate over several kilometers, and in open areas they can even reach well over 10 kilometers. The setup is pretty simple. At first, I have one LoRa module connected to an ESP32 that stores my music library. On the phone side, there's another LoRa module connected to a second ESP32 which pings directly into my phone through USB. Together, they create a direct wireless link. No Wi-Fi, no cellular network, no internet. To get this working, I had to program the ESP32 modules. Now I'm not going to talk about the code in detail, but here's the basic idea. The transmitter reads the AI compressed song from storage and splits it into small packets. Each packet is sent over LoRa to the receiver one at a time. The receiver keeps track of every packet, requests any that go missing, and stores everything in the correct order. Once the entire file has arrived, it feeds the data into the smartphone app that does the reconstruction of the song. And finally, here's the app. It has two modes. The first is scan tape. Just scan the front and back of your QR cassette and the app automatically stitches all 8 QR codes together, reconstructs the audio using the AI decoder and starts playing the song. The second is stream. Instead of scanning a cassette, you simply pick a song from your library. The app requests it over LoRa, downloads the compressed data, reconstructs it and plays it. All you need is the LoRa receiver plugged into your phone's USB-C port. And here's what it sounds like.
They're shining so bright, we're gonna dance through the night. Hands up, feeling the heat. Move your body to the beat. Step by step, we start to glide. In this moment, we can't hide.
All the experiments, coding, and AI finally led to this. A single piece of paper that contains an entire song. A few days ago, this was just a stupid idea I couldn't stop thinking about. Now, it's actually playing music. No internet, no cloud, no servers. Now, is it perfect? Not yet. The audio quality still has room for improvement, and the music is just over a minute long. But I think this is a pretty exciting first step. If you have any ideas for improving it, I'd love to hear them in the comments. And if you end up building your own version, definitely let me know. I'd love to see what you came up with. Thanks for watching, and I'll see you in the next one.